Sir, we are live, sir.
Yeah.
So, good morning once again. So, we welcome you all to the 5 days FTP on recent advancements in automation technology in achieving Industry 4.0. So, on behalf of Chennai Technology, we thank you all for joining this 5 days FTP. So, today we have Dr. M. Threselvam, experienced professor and Dean of Research and Consultancy from National Institute of Technology, Tiruchirappalli with us. So it is our great pleasure to welcome him to this 5 days FTP. We welcome you, sir.
Thank you, Daniel.
Thank you, sir. And now I welcome Keshavarshini, first year mechanical engineering student, to introduce our today expert. Keshavarshini, you can start. Okay. So let me introduce sir to this forum. Sir, Dr. M. Threselvam is working as a professor in Department of Production Engineering, and he is having more than 100 research publications in reputed high impact factor journals, and he is working on laser material processing, tribology, and so many with so many industrial projects, and he has got a lot of funding from AICTE, DHCSERV, and BHEL. So it is our great pleasure to hear such an expert in this 5 days FTP. It is our pleasure, sir. Please, you can go on with your questions.
Yeah, thank you, Dinaran, for giving me an opportunity to deliver a talk in this wonderful forum. And always, I'm very happy to join with you whenever you are organizing this kind of funded events. And earlier, in one more program, a couple of months before, we talked about more on advancement in lasers. And slowly, we also started working on some of the digital manufacturing related concepts. And since I am associated with Siemens Center of Excellence in Manufacturing, where we do a lot of end-to-end PLM solutions like this product lifecycle management solutions, and hope our experience in digitally converting the traditional manufacturing systems to advanced systems, and this being a mechanical engineering background, I limit my scope of discussing only some introduction to Industry 4.0 and what is really needed to convert your existing manufacturing systems to adapt to this wonderful technology, Industry 4.0. And I request some moderator be with me throughout the lecture because the audience sometimes may face some difficulty in viewing the slides, or they may have some difficulty in sometimes when I will be changing the slide, but in other end the slide will get freezed. So I need one person to stay throughout the lecture so that whenever this kind of a difficulty, they can try to resolve immediately. And since
yes, sir, I will be with you, sir. I will be with you, sir.
That is wonderful, Dinagaran. Yeah.
Fine, sir. Thank you, sir.
Yeah. So this is the content. Let me start with a brief introduction. And this Industry 4.0, it is nothing but the fourth industrial revolution. And before talking about this fourth industrial revolution, I will also give a very brief outline of what happened in the first industrial revolution, second, third, and right now what we are aiming at to do that one. When I look at that entire lecture schedule, the previous lecture also, it is more of industry Internet of Things. And you can interfere me if something that I am repeating. For example, if the previous speaker, when he talked about first revolution, second revolution, third revolution, probably can stop me. Already it's been handled, so that I can skip to some of the other topics which may be more relevant and which will have a lot of value rather than repeating the same content, right? And we'll also talk about what are the different components required and some of the applications of IoT. IoT, sometimes there is a misconception that Industry 4.0 is IoT. It's not actually replica, right? You can't say IoT as a Industry 4.0 because IoT is needed. IoT is the skeleton over which we are building this Industry 4.0 concept. We can comfortably term this as a industry Internet of Things. So industry Internet of Things should be Industry 4.0, not IoT is equal to Industry 4.0. So we have to be very clear in this. For example, this concept of IoT that can be used in a variety of verticals. If you are using it in a home, then it is a IoT-enabled home or a smart home. When you are using this IoT technology in medical industry, that is Internet of Medical Things. If you are using to save electricity or electrical generation systems, then they are terming this as an Internet of Electrical Things. Likewise, it found a lot of applications, and wherever it can fit in, they started using it very effectively. And from the perspective of our industry, how we are transforming to the next level, that can be termed as Industry Internet of Things. That is Industry 4.0, not IoT. And we will also talk about some of the IIoT enablers like cyber physical systems, cloud computing, edge computing, big data analytics, AI and machine learning, because these are some of the building blocks through which you can realize this Industry 4.0 application in a real industry. And if you are a mechanical engineer, you should have a lot of interdisciplinary information or knowledge background to understand how this Industry 4.0 really works. You should have knowledge of computing, artificial intelligence, data analytics, a lot of AI, more particularly AI and machine learning, that plays a very crucial role in realizing the Industry 4.0, because if your AI system is not capable of making decentralized decisions on its own, then the complete purpose of talking about this Industry 4.0 cannot be solved. So that these are very, very important. And moreover, the data analytics, how effectively your system is capable of picking up the right data that is needed for understanding your system performance, that's very important. So it is a combination of different technologies, and altogether this will lead to a leap forward in the way in which we do manufacturing. So this is the way I organize the content, and I will try to fit into the schedule. So they have given 1.5 hours, that may be a little longer. Let me see how much that we can talk about in these different topics. When you look at the different evolutions like Industry 1.0, Industry 2.0, 3.0, now we are talking about 4.0. Most of the cases, these different evolutions that have happened based on need. So whenever there is a need, they used to go to the next level. Whenever there is a new technology is coming in, they try to use the technology and think about in a different way how the things are working. And now the question is, why we need Industry 4.0? What really, is there any problem with the present system? Absolutely no problem. We are doing perfectly well, but there are certain gaps. that need to be addressed in this competitive environment. That is where the Industry 4.0 makes a very good impact. The first thing is this Industry 4.0 enable rapid manufacturing of new product. New product manufacturing or introduction of new product, it is not a very new thing. And our Indian market is quite accustomed with a huge amount of new product introduction. And our customer preferences are changing very frequently compared to previous years, where we have a manufacturer-driven market. The market is completely dominated by the manufacturer, and you have some limited options. So within that options, you need to pick up what you require, and you don't have much competition. And they put up very huge margins as a profit, and they're selling at an unrealistic prices in the earlier days. But presently, the situation is completely different. For each and every product, you have a lot of competitor, and the trend is also changing more frequently. And when considering these cases, you need to roll out a new product every 3 months, let us say every quarter, so that you can survive in the market. Considering this fact, how it is influencing your manufacturing line, your product line, that's very important. And you might have got some kind of fixed systems for producing in a mass quantity. And if some changes that is influencing your production line, then these are some of the capital investments that you have made as a fixed cost. And if you wanted to change this, that may be very, very complicated. And when your system is very flexible, but the batch sizes that it can handle is very minimum. So we need to have some kind of a trade-off. Okay, what are the changes that you are talking about? Your manufacturing system is capable of adapting. So that is the kind of a system that we are talking about. And moreover, some of the cases when we are trying to identify the customer preferences, there may be some kind of a sacrifice. For example, let us say in this particular program, FDP, we have some 30 plus participants, let us say. And if I am giving a survey to each participant and wanted to get a feedback of your preference, if I am launching a new product, right? So you come out with a set of preferences. The person 1 will come out with a set of preferences. The person 2 will come out with a set of preferences. And all the 30, when I collect that and when I try to consolidate, there may be a surprise that all the 30 may be requiring a completely different set of requirement, or there may be some overlap. Some requirements are not very common, something like that. And if I wanted to accommodate all the 30 varieties, but my manufacturing systems is not too flexible to accommodate all the stuffs. So what normally we do, we take some of the common features, what is a product is consisting of, and rest of the features that we will ignore. That means in this kind of a moderate flexible system or a fixed system, approximately will serve 70 to 80% of the customer. That means I am afford to lose 20% of the customers. But this Industry 4.0, it's very, very unique. If you have a very unique requirement, okay, you give that requirement, we will do it. The second person also having a unique requirement that is possible to produce. And likewise, if we have a 30 varieties with a limited quantity or a mass quantity, our system is capable of adapting that one. One best example is now you can build your own car. For example, go to any advanced car manufacturer website like Volkswagen or Audi, and you can choose the color, you can choose the type of alloy wheel you want, you can choose some of the interior, the design, everything. Finally, if you click build the car, it will give the price. If it's okay, if you click and pay, then it will go to the manufacturing. So likewise, the systems are so advanced now, and unless otherwise you have this kind of flexible strategy like Industry 4.0, it's very difficult to adopt this kind of changes. So the rapid introduction of new product varieties that you can handle very easily with this Industry 4.0 compared to Industry 3.0. Then dynamic response to product demand. Product demand that will be varying based on a lot of external influencing parameter. We have very good systems in practice to predict or forecast the demand, like we do weekly forecast, monthly forecast, or yearly forecast, and a lot of data that's being used to predict what is going to be the demand in the future. But sometimes all these predictions will fail. Nobody predicted the airline market going to steep fall in 2020. So when they are in 19 or when they are in 18, based on the previous sales of air tickets, air traffic, they might have projected in 2021 they'll be earning billions of rupees considering the past data. But due to the COVID, due to this kind of a sudden pandemic or outbreak of this virus, every prediction have gone wrong. But this Industry 4.0 that have a very good capability of learning the systems, and dynamically it will try to understand how the future going to be, in the near future going to be. Accordingly, you can adjust the product demand. So what I mean to say is the industry, a very good Industry 4.0 system is a very dynamic, by which you need not have a huge amount of raw material. Whenever you require, you can place the order for your raw material, by which you can produce the product in a more competitive pricing. Then real-time optimization of manufacturing and supply chain networks. So that is very important because almost 30% of your product cost goes into logistics. And when you are having an optimized logistics system, then possibly you have the possibility to reduce the total product cost. So everywhere we try to optimize the product cost, by which compared to your competitor, you can give it as a very, very competitive price. So it has a possibility to optimize in the real time. So these are some of the major driving force of Industry 4.0 that what we can say. So it will enable rapid manufacturing, dynamic response to product demand, real-time optimization of manufacturing and supply chain networks. That's highly possible with Industry 4.0 concepts. So basically, it's what we are talking about. It's a more of interconnectivity. So it focuses on interconnectivity, automation, machine learning, and real-time data. And it combines physical production operations with the smart digital technology, machine learning, and big data to create a connected ecosystem for industries that focuses on manufacturing and supply chain management. So that is the core concept of this Industry 4.0. So industrial revolutions, first, it is more of mechanization. Water power and steam power was dominating at that time. In the start of or late of 18th century and the early 19th century, that period that is being termed as the first industrial revolution. The second, it's more of a mass production, and the early part of 20th century witnessed that one. Since electricity came into invention as one of the important invention, then telephone line, telegraph networks, railroad, lot of important progress that has been made in the early part of 20th century. And in the late 1950s, we got computer automation, which integrated into this production line, and by which it has a different revolution. Third, and the fourth, since 2010, only one decade old, we talk about cyber physical systems that we will discuss little in detail. To give just a few minutes of understanding what is this different revolutions. First industrial revolution, it is a transition to new manufacturing process in Europe and the US in the late 18th century to 19th century middle. and from hand production method to machines, new chemical manufacturing and iron production processes, the increasing use of steam power and water power. So mostly the first industrial revolution that dominated with the steam and water power, right? And the picture what is you are seeing, it's a Robert's loom in a weaving shed in 1835. Textiles were the leading industry of the industrial revolution. And this is, in fact, began in Great Britain, and many of the technological innovations were of British origin. By the mid-18th century, Britain was the global trading empire with colonies in North America and Caribbean, and with a political influence on the Indian subcontinent. And you may be also knowing the Bengal Subah through the activities of the East India Company. And through that, they invaded our country some hundreds of years before. And the development of trade and the rise of business were among the major causes of this industrial revolution. Roughly, the second industrial revolution that can be termed as a technological revolution, and that happens approximately between 1870 to 1914. Some of the books, they will give a different timeline, and these are very arbitrary. No one can predict exactly, okay, this revolution ended this period, this revolution started this period. Roughly, during that time, this kind of revolution may have happened. And advancements in production technology that enable the widespread adoption of technological systems such as telegraph and railroad networks, gas and water supply, and sewage systems. These are the systems that is driving the second industrial revolution. An enormous expansion of rail and telegraph lines after 1870 allowed unprecedented movement of people and ideas, which culminated in a new wave of globalization. And this really created a lot of movement of people. And earlier, you need to depend on some kind of bullock carts or some transportation systems. So it will take some months to reach a place. But once this railroad has been developed, people started moving very easily, and as well as ideas. Whenever people started moving, ideas also started moving. So this has created a wave of globalization. So in the same time period, new technological systems were introduced, more significant electrical power and telephones. So the second industrial revolution continued into the 20th century with the early factory electrification and the production line, and ended at the beginning of World War I. So it abruptly stopped when the World War I begins. Steel, as I said, that is a dominating industrial revolution, second one. And the Bessemer process, invented by Sir Henry Bessemer, allowed the mass production of steel, increasing the scale and speed of production. And the picture what you're seeing, it's a Barrow Hematite Steel Company, operated 18 Bessemer converters and owned the largest steel works in the world at the turn of the 20th century. Very, very, very big steel plant. And the rail, so once you started producing steel, you have a very good use to form railroads, and the commonly used iron without any processing is steadily getting replaced with the steel. So electrification started replacing the steam power, and the theoretical and practical basis of harnessing the electric power was laid by the scientist and experimentalist Michael Faraday, and his inventions of electromagnetic rotary devices were the foundation of the practical use of electricity technology. And the picture what you're seeing, it's Sir Joseph Swan invented the first feasible incandescent light bulb in 1881 and supplied about 1,200 Swan incandescent lamps to the Savoy Theatre in the city of Westminster, London. This is the very first public building in the world to be lit entirely by electricity. So in 1881, this is the Savoy Theatre that got electrified by a bulb. Now, you might be clearly knowing that without electricity, nothing will move in the world. So we all depend on electricity. And I'm communicating from Tiruchirappalli, and you are sitting at different parts of the our country, and you are witnessing a kind of a lecture through internet connectivity, and without electricity, it's very difficult to imagine this kind of advanced systems, right? So that is the way electricity come into picture. Petroleum, again, it is another important invention, and the petroleum industry began in 1848 with the first oil works in Scotland. Many do believe that in Middle East, but it is not that. It's in Scotland. And the chemist James Young set up a small business refining the crude oil in 1848. In 1850, Young built the first commercial oil works and oil refinery in the world at Bathgate, using oil extracted from locally mined torbanite, shale, and bituminous coal to manufacture northern lubricating oil. At that time, to be frank, they didn't know that's having a very huge usage in the world. It's going to be a very disruptive technology of the future. It is going to fuel a lot of automobiles, electrical systems, everything. They don't know. They just started using it for lubricating oil. Automobile, again, it's the greatest invention. The German inventor Carl Benz patented the world's first automobile in 1886. It featured wire wheels with a 4-stroke engine of his own design, with a very advanced coil ignition and evaporative cooling rather than a radiator. Parallelly, around that time, Henry Ford also built his first car in 1896 in US and worked as a pioneer in the industry. So these two, Carl Benz and Henry Ford, still we are seeing their Benz and Ford brand from Europe and United States, and they are the initial starter of this automobile industry. And the third industrial revolution, what we can say, this is a digital revolution. So computers have come into that one. We started using PLCs, and from the mid of the 20th century, we can term this third industrial revolution as the digital revolution. And there's the shift from mechanical and analog electronic technology to digital electronics and proliferation of digital computers and digital record keeping that continues to the present. Still now we are completely using this digital technology. There is no doubt about it. And brought semiconductors, mainframe computing, personal computing, and the internet. These are very good parameters or very good systems that contribute to the digital revolution, and gave rise to the era of high-level automation in production with two major inventions. One is PLC and another one is robots. So these two make a lot of automation in the production line, by which the manual errors have come down. You can go with a very, very high level of mass production, and the machines can be programmed, the sequence of operation that need to be put on a product well in advance, and very good repeatability that also been achieved with this kind of system. So the electronics and information technology began to automate production and take supply chains global. So this is very, very important revolution, and that the digital technology contributed in a high level. Many people think about automation is Industry 4.0, right? So automation is not Industry 4.0. Automation is there in Industry 4.0, but Industry 4.0, that is beyond automation. Beyond automation, what that the system will do, that is all about Industry 4.0. So roughly in 2011, almost a decade before, it originated in Germany, and they introduced the term Industry I4.0 or Industry 4.0. Here the technology is machines are augmented with wireless connectivity and sensors connected to a system that can visualize the entire production line and make decisions on its own. Now you can feel the difference. Earlier we talked about automation. Automation using PLCs, it is a programmable logic controller. So logically we do some kind of a program. Accordingly, the system will get automated to do some kind of a repetitive action, repetitive motion, or a repetitive job. But it won't take any kind of a decision by its own. But what we are talking about in Industry 4.0, you have a wireless connectivity of the machines, use the sensors to collect data, visualize the entire production line, and make decisions on its own. Whenever your system is making decisions on its own, that means it is acting very smart, right? So that Industry 4.0 also can be termed as smart factory or smart manufacturing systems. That really means industrial Internet of Things or Industry 4.0. So I think you are now clear with the point. What is the difference between the automation and Industry 4.0, or what is that we have done in Industry 3.0, and what more we are doing with the Industry 4.0. And the trend towards automation and data exchange in manufacturing technologies, which includes CPS, that's very important, cyber physical systems, IoT, cloud computing, cognitive, all those stuff really required to realize this Industry 4.0. In smart factories, CPS monitor physical processes, create a virtual copy of the physical world, and make decentralized decisions. So what does that happen in the physical world? It will take exact copy of virtual manner, try to do a lot of computations, and decentralized manner, it will try to influence the physical process. So that is the base of this understanding of different revolutions. And what are the different components that is required to realize that Industry 4.0? So when I refer many forms, lot of the list expands, more than 100 different components that may require that in order to realize this Industry 4.0 concept. Like you need a kind of a mobile device, you need IoT platform and a location detection technologies, advanced human-machine interfaces, authentication and fraud detection. You need a 3D printing system. You need a smart sensor. Likewise, the list goes on and on. Roughly, when you try to pick up those things and put it in a basket, it will fall in these four categories. One is cyber physical systems, IoT, cloud computing, and cognitive computing. For example, this big data, all these things will come into cloud computing, IoT platforms and other things will come into IoT, and cognitive computing, this artificial intelligence, data visualization, everything will come into this cognitive computing. And this cyber physical systems, you have mobile devices, 3D printing, sensors, everything will come in these systems. So likewise, to realize this Industry 4.0, you need to develop a cyber physical system, you need to have an IoT platform, you should have a cloud computing storage system, and a cognitive computing, that means artificial intelligence and machine learning component. Before talking about this Industry 4.0, we'll give some clarity on what is really IoT, right? IoT, this is the backbone of Industry 4.0, and IoT do have a lot of applications. And once you understand clearly this Internet of Things, then possibly you can build your smart factory over this IoT platform, right? So IoT, it is an ecosystem of connected physical objects that are accessible through the internet. So simply, we need to connect the devices, right? So the thing in IoT could be a person with a heart monitor or an automobile with a built-in sensors, that is objects that have been assigned an IP address and have an ability to collect and transfer data over a network without manual assistance or intervention. So that is very important. And the embedded technology in the objects helps them to interact with internal states or the external environment, which in turn affects the decision taken, right? So you have an internet connectivity, you have a thing, the thing may be a machine or even a person. For example, if I am wearing a smartwatch, I am connecting through the net, and all my body parameter like heartbeats, saturated level of oxygen, and how much distance that I have walked, and a lot of this kind of a parameter, when it is being connected to a device and supplied to transfer to some kind of cloud platform, then that means indirectly I got assigned with an IP address, right? So if a machine or an automobile that has a similar kind of data that is being transferred through kind of a device and then pushed to the cloud, that means the automobile have an IP address, right? So whenever you are assigning the things some kind of an identity, connecting to the net, collecting the data, taking a decision based on the data, that is all about IoT. Very simple, right? So that is the way we put in some smartness in controlling different activity. So that is where the level of the smartness that really gives the real competitive advantage between different manufacturing systems. The concept of smart devices was not new. Even in early 1982, they talked about this IoT. They implemented the IoT concept with a modified coke vending machine at Carnegie Mellon University that became the first internet connected appliance, and it able to report its inventory and whether newly loaded drinks were cold or not. So it will have some kind of a sensor to measure the temperature continuously, and the temperature will get into some kind of a database, and if the temperature is coming down to the threshold value, then it will give a signal that it's coming down, and also it reports an inventory. So that is very base origin, or a very older systems where they really talked about in IoT, but due to that poor network connectivity and other related issues, the technology is not picking up very well. But we are now talking about 4G, and 5G also going to come in usage in the near future. Then you have a lot of opportunities to collect the data very easily over wireless networks. Some of the appliances, some of the applications of IoT, just to give some glimpse of information. From the consumer point of view, you can go with a home automation, connected vehicles, wearable technology like a smartwatch, what I have talked about. This is one of the IoT application. And smart home. Nowadays, if you have a IoT platform, then you connect all your electronic appliances like lighting, heating, air conditioning, media and security systems. Then you program it how it has to behave, then it will automatically sense and do that one. If you have some artificial intelligence built in your IoT platform or in your system, then automatically it will try to learn your entire home and try to behave accordingly. So such a kind of advancement that's already in practice, and a lot of IoT platforms or hubs that is already available in the market in the brand name of Amazon Echo or a Google Home or a Apple's HomePod or a Samsung SmartThings Hub, a lot of things. So that is one of the important applications of IoT. And medical and healthcare, you do have wonderful opportunity. If someone wanted to do the future course of research or some kind of entrepreneurship, you can think about doing something on medical related field or healthcare related field, because they started connecting the human healthcare related parameter through internet, some kind of artificial intelligence systems that monitor completely, by which a lot of savings, savings in life as well as money that they are reporting, and the way by which they are predicting some kind of problematic situation that is compared to the present medical practices. It is more than 24 or 48 hours in advance. To cite a simple example, for example, I have take an example. I have registered for monitoring my health parameter to some kind of a system or a network that is floated by a doctor, for example, and I may need to pay a usage fee. And for example, they might have put some sensors in my body, and all the data will be pushed to the cloud, and their platform will be having some kind of algorithms that completely characterize my parameters supplied by the sensors. And if it predicts that I am going to be very sick in terms of my blood pressure is increasing unusually, or I'm going to get a heart attack, in 24 hours to 48 hours, then possibly it will give an alarm signal to the, practically the doctor himself may not have time to look at each patient's data. Maybe 5,000, 50,000 patients might have registered for in his network of this monitoring system. So the system will give an alert signal, and that alert signal directly alert to an ambulatory service. The ambulance will come to my home, and I will be doing some, regular activity, but the guys will come and say that you are going to get a heart attack in 24 to 48 hours, so you need to get admitted to the ICU. Rather than getting into heart attack, trying to save the life, and that is the difference by which this IoT help in medical things. So that is a kind of life-saving things that can be thought about in this case. And this Google AI that's having a lot of important developments in terms of adapting IoT technology in medical field. And they are taking your eye scan, retina scan, to characterize what are the kind of health issues that you have. So based on so much of data, they wanted to learn using machines and artificial intelligence algorithms. And one study that Goldman Sachs what they say, the healthcare IoT devices can save the United States more than 300 billion in annual healthcare expenditure by increasing the revenue and decreasing cost. So what they mean, if in the US, for example, they might have insured a huge money on their lives. So when a life suddenly goes, the insurance agency has to pay a huge amount. Rather, if you have this kind of life-saving systems, and what the survey says, more than $300 billion of annual savings in this healthcare expenditures, that's a very huge amount. You can think about a simple technology, how revolutionize the entire world. Then transportation, again, it can assist in integration of communication, control, information processing across various transportation systems. And the dynamic interaction between these components of the transport system enable inter and intra-vehicular communication. For example, now we are talking about driverless vehicle, autonomous vehicle, a lot of things. That is the futuristic technology that completely depends on this IoT-based platform only. So the cars will communicate with each other. And it will communicate with some centralized console, and by which your transportation systems will get into the next level. Smart traffic control, smart parking, electronic toll collection systems. Now we are witnessing this electronic toll collection. You need not wait in a queue these days. It will sense with a tag when it is going, and automatically from your wallet the money is getting deducted, and not necessarily you have to give a static speed limit. Let us say based on the traffic density, the speed limit can be varied. So that is some of the advancements. In fleet management, an IoT platform can continuously monitor the location and conditions of cargo via wireless sensors and send specific alerts when exceptions occur, like delay, damage, theft. And even when you are importing something from foreign country, it will come with the small sensors put into that boxes, and wherever you travel, it will continuously track your package and tell where it is right now. And if there is a sudden damage, that also will get reported. If somebody is trying to, take it away, then it will continuously track and will give the signals. So likewise, the fleet management is going in a very advanced manner. So IoT, that makes it realize that one. So finally, how that IoT in transport, how it has been used in education, how it is used in a home, and the entire business that comes into a kind of a network. Again, you are going to connect with the network. So it becomes completely network of networks, right? So that you will be having a very good security. You will have a very good management of all your activity. You will be having a better living experience in the world. So that is the future, what we are looking for using this IoT-based technology and adapting in your day-to-day life. So coming to our core, industrial IoT. So this industrial Internet of Things, or this Industry 4.0. Here, as we have seen in the home, as we have seen in the medical devices, medical or healthcare industry, transportation industry, how we have connected the things, similar thing we are going to follow in a industry. So that is why it is Industry 4.0, right? So it's a seamless integration of various manufacturing devices equipped with sensing, identification, processing, communication, actuation, and networking capabilities. So that is all we do to realize that one. And extends itself to assess asset management via predictive maintenance, statistical evaluation, and measurement to maximize reliability. As we have seen some kind of a predictive technology earlier, if some commands or some alert signal that if you get that the machine is going to fail in 24 hours time, then we can predictively trying to make it into live again when it has been continuously used. It can also be integrated with smart grids, enabling real-time energy optimization and measurements, automated controls, plant optimization, health and safety management. These are provided by a large number of network sensors. So these are the IIoT enablers. You have, as I said, cyber physical system, cloud computing, edge computing, big data analytics, artificial intelligence, and machine learning. So in order to realize this Industry 4.0, you need these different components. Let us have a look at it a little in detail, not too much. And the CPS, that is the cyber physical system, is the integration of computation, networking, and physical process, embedded computers and network monitor and control, that is computer-based algorithms, the physical process with feedback loops where physical process affect computations and vice versa. So what I mean to say is, in the cyber physical system, you have a physical system, you have a cyber system, both are connected together, but the core Industry 4.0, what it says, connection not through wired, only through wireless. So that you have a very good flexibility, right? So if you have a sensor to collect some critical information from the machine, like what is the tool wear, what is the diameter that it is drilling, what is the depth of the hole, what is the surface roughness, all those stuffs, when you have a sensors to monitor and take the signals back or data back, and you have an actuator which will move according to the command what you are giving, it will perform some kind of motions, and this can be categorized as a physical system. And you may be having some kind of computing devices, storage devices, and a communication network. All these kind of things are a cyber system. So CPS, when you integrate all those things, the cyber and physical, it will work as a cyber physical system. And what is the level of the smartness your CPS system is having? That depends on what are the kind of algorithms that you are using, what is the kind of level of data collection, level of that cognition that you are giving as an input, that is really a determining factor. So it can be explained with the 5C architecture. You start with a connection, then go with a conversion, cyber, cognition, finally to the level of configuration. In a smart connection level, what happened? It's like more of a plug and play system. And you have a sensor network, a tether-free communication. Simply, it will try to do some kind of connected devices, right? Then data to information, that is conversion level, like the smart analytics, component machine health, then multidimensional data correlation, some little level of smartness that you are giving. In the cyber level, you get a twin model for components to machines. You have a virtual as well as physical, that's twin model. And the time machine for variation identification and memory. For example, go to the next week and try to find out how your system behaves. Goes to the next month. It's a time machine, like what we have seen in the movie. If you're doing this kind of an operation in the time machine, go forward and see how your system is performing. It's in a cyber level. Cognition, some kind of thinking. Your system will be capable of having some kind of a thinking, and based on that thinking, it will try to take some kind of a decision, like integrated simulation and synthesis, remote visualization for human, and collaborative diagnostics and decision making. Some kind of decision making in a configuration level it will take. So finally, the cognition level. So finally, in a configuration level, it's a self-configurant for silence. Whenever there's kind of some disturbance, it will try to self-configure, self-adjust, self-optimize. So that is the level of the CPS system, what we are talking about in a real industry 4.0. So whenever something happens, it has to self-adjust. Whenever it has to do some kind of an optimization, it has to self-optimize. So the kind of algorithm, the kind of a machine learning, and the kind of experience that you are giving to the machine to understand the environment by which it will go to the level of configuration. So that is the highest level of the CPS system. So that is what given in this text. And the cloud computing, again, it is another important system or a component in Industry 4.0 realization. And this is simply storing your data somewhere in a third-party storage devices. That is simply cloud computing. And cloud means you don't have any idea where it's being stored, but you do have an idea who is running that third-party storage systems, and pay per use. You pay and use their storage systems. Normally, the storage is very expensive. For example, if you are a Industry 4.0, if you wanted to have an Industry 4.0 implemented in your industry, for example, you are let us say an automobile manufacturer, you may need a 300 terabyte or a 3000 terabyte of storage requirement. For example, okay, you purchase all those storage that may be running into few crores, right? You have a storage, and this storage need to be expanded for again another 3000 terabytes, because you are going to introduce a lot of one more production line. Okay, you introduce 3000 terabytes. Later, there is a reduction in demand, so you are not going to use 50% of your production capability. Suddenly, your storage requirement will come down. But you physically have a 6000 terabyte storage possibility, but periodically you may not be using 100% of your storage requirement. So this additional unused storage, it's going to be a waste of money. So most of the leading manufacturers nowadays, what they are doing, they don't purchase hardware to store their data, rather they will rent out. It's a simple cloud computing. So go for some third-party storage vendors by which you can use their facility. And some of the benefits of this cloud computing is self-service provisioning. You don't need any kind of IT administrators. Elasticity, you can scale up or scale down. As I said earlier, if you don't need, don't pay. You tell in the next month, I don't need 6,000, I need only 3,000. Definitely it's possible. You pay only for the resources utilized. And workload resilience, ensure resilient storage and keep users important workloads running. Migration flexibility, you don't like the storage capacity. Now you have, rather than SATA, you have SSD. Your hard disk technology is changing to a new level. And if you're already using some other storage device which is using SATA, which is very slow, you terminate that contract and go to the SSD, which is very, very much possible, right? So you have a very good migration flexibility when you're storing the data. Some of the example of service categories of cloud computing, you have a SaaS, PaaS, and IaaS. IaaS, a SaaS is a software as a service, and PaaS is a platform as a service, and IaaS is a infrastructure as a service. And you might be somewhere during your day-to-day life might be using any of these platforms. Software as a service, for example, if I wanted to convert my image into PDF, I directly go to Google and look at for some online or conversion tool. This is actually software. somewhere the software is located in the cloud, and I am using that software to do something what I require. And sometimes there are platforms are available. You can use that platform as a service, or infrastructure itself. You can use it as a service. Like the software converting your image into PDF, it's a very simple example. You don't need to pay anything, but when you wanted to use a platform as a service or infrastructure as a service, definitely you may need to pay something to use their platform, use their services. So likewise, when you are using a storage devices, that is infrastructure. You need to pay for use. Edge computing, it is more or less similar to cloud computing. The only thing is the sensors will be taking data in terms of gigabytes. You don't need to store all the data, so you need to filter at the edge of the network. So all your machines have a lot of sensors. Let us say you have 10 machines. Each machine have 10 sensors. That means 100 sensors. Each sensor will be taking huge amount of data, and all those data will go to this edge node, and where it will filter out some of the noises, and only the data what is need to be analyzed, it will be sent to the cloud, because you are paying in the cloud for your storage space. Big data analytics, it's a wonderful field, and if you wanted to analyze the data in an appropriate manner, you should have a lot of understanding of this big data analytics. It will really uncover a lot of informations, like your data will be having some kind of hidden patterns, unknown correlations, market trends, and customer preferences. For example, if you have collected some 1 lakh data, and from that, if you are able, if your data analytics is capable of picking up some of the important customer preference, and if your competitor is unable to pick that preference, you have an edge over the competition. That's very, very important. So that can help organization make informed business decisions. Just like that, I can't go, okay, the future is maybe like that. You can do, your actions can be like that, something like that. No. You have a data, the data is showing this is going to be the trend, this is going to be the preference, this is going to be some kind of a requirement. So accordingly, you can take an informed business decisions. For that, the big data analytics is very important. So in our industry 4.0 also, how you are analyzing the collected data using these concepts, that's very important. So big data challenges include capturing data, data storage, data analysis, search, sharing, transfer, visualization, querying, updating, information privacy, and data source. A lot of things are involved. For example, capturing data, how quality is your sensor that is capturing data? If there is any noise in the data itself, all your total system will collapse. So the quality of data, what is getting collected, that depends upon the quality of the sensor, right? So how you are capturing, how you are communicating. When you are communicating, there should not be any data loss, right? When you are storing, there should not be any distraction of the data. When you are doing an analysis, it has to be proper. So all these requirements are very, very important. When you look at that global information storage capacity, it's a little old data, but when you look at that, the analog, it is almost 2.6 exabytes in 1986, but it has grown only to 19 exabytes. And the digital, in 1986, the requirement compared to analog is very small, only 0.02 exabyte. Now, almost 10 years before itself, the digital data requirements is 280 exabytes. I think it is 10,000 terabyte is 1 exabyte. Let us see that. Then another important component to realize this IIoT or Industry 4.0 is the artificial intelligence. So how your algorithm is capable of producing a self-configuration, self-adjusting, self-optimization, that really matters in converting your normal system into a smart system, right? And it is more of a simulation of human intelligence processed by machines. And these processes include learning, like the acquisition of information and rules for using information, and reasoning, self-correlation. And you can say there are two different types of AI, either it's a weak or a strong. Weak AI systems that is designed and trained for a particular task, like a virtual personal assistant such as Apple Siri, or a form of weak AI, even the voice recognition software that is in the Android mobile, like a Siri. Whatever you speak, sometimes it will translate properly, but sometimes it may not, because due to that the voice distraction, the mic, when it is capturing the data, it may not properly get decoded. But there is not going to be much problem when it's interpreted in a little wrong manner. But in a real systems, this is very, very important. If your system is not responding properly according to the command what you're giving, then it's not be a very good system. So in a strong AI, it has a generalized human cognitive ability. When presented with an unfamiliar task, a strong AI system is able to find a solution without human intervention. That is a kind of system what we are looking at. You give an unfamiliar task, and the AI system able to find a solution without human intervention. These are some of the components of AI from the application perspective, like an image recognition, speech recognition, chatbots, natural language generation, and the types of models. Either it may be a deep learning, machine learning, or a neural networks. And some of the software, hardware for training and running these models, GPUs, parallel processing tools, cloud data storage, and the programming languages like Python, TensorFlow, Java, C are important. A lot of different types of artificial intelligence. I'm not going to deal much about that, just to give a glimpse of information, like reactive machines designed for a narrow purposes and cannot easily be applied to another situation. So Deep Blue, the IBM chess program that beat Garry Kasparov in 1990s, Deep Blue, it's a AI system that will only work on the decision when different coins are moved in the chessboard. And the limited memory, it's another artificial intelligence, theory of mind, self-awareness. AI systems have a sense of self, have consciousness. Machines with self-awareness understand their current state and can use the information to infer what others are feeling. So like a human, you give this self-awareness to the machines also. So such a kind of a system, what they are really talking about. Some of the applications of AI in a healthcare, applying machine learning to make better and faster diagnosis than humans. Business, like machine learning algorithms are being integrated into analytics and the CRM platforms. Education, automate grading, assist students like AI tutors, perhaps even replacing some teachers. Here, comfortably, I have put some teachers. Maybe in a decade, all the teachers, who knows, will get replaced with robots. Robot don't ask for salary, don't ask for a time constraint, and it will teach better than the humans, right, without tiredness, and it will individually assist every students. It will individually select teaching modules depending upon the student learning capability, which a normal teacher cannot do. We just try to cluster the student group, who is a best learner, better learner, and worst learner, and accordingly we can give some 3 or 4 different learning methodologies. But a robot can give 50 or 500 learning methodologies depending upon their capability in order to make them make everyone learn. And finance, in a near future, the physical banks may not exist. Like everything will get automated. You don't see much of physical currencies in the near future. And in a law, computer assistants that can sit programmed to answer questions by examining the taxonomy and ontology associated with the database. So no more codes, and the judgment can be instantaneously done by a robot or an artificial intelligence system. And perhaps the manufacturing also, what we are talking about, a very good quality control, shorten design time, and reduce material waste, perform predictive maintenance. A lot of things completely get automated. Hope you know that the Sophia, the AI robot, which got the cities. I have these different videos, but unfortunately, due to the limited bandwidth, I'm unable to share. This again some factory model, how in a realistic situation when you wanted to um, control the changes what is happening automatically without any human intervention, that is being given in this particular video. And Amazon, that is one of the biggest online store that is selling lakhs of products, and how they are using this Industry 4.0 concepts to automate their entire material handling systems and warehouse logistics systems in order to serve the customers with the minimum possible time. That is one of the beautiful videos. You can download all those videos in the internet, and you can see and how they have used that data to improve their handling capability, smartness. And most of the automobile manufacturers started adapting this Industry 4.0, being a German-originated technology. Volkswagen, Audi, everyone started incorporated this Industry 4.0 for improved performance or improved servicing to the customers with a reduced cost and meeting a lot of varieties. So with that, I hope I have given some information related to what is really Industry 4.0, what are the components that really required to meet the standards of Industry 4.0, and how your system can be made smart in terms of manufacturing. And many of the European and US industries, when they are building, they build with Industry 4.0 concepts. Some of them, they try to convert their Industry 3.0 systems to Industry 4.0. But India, we are still slow in converting, meeting the standards of Industry 4.0, because some huge investments are required, and your factory automation, when it is need to be integrated with so much of sensors, actuators, Wi-Fi connections, and training them to go forward to the next level, that's again a huge challenge. And but if you're not upgrading to Industry 4.0 in the near future, then it may be very difficult to survive in the market. And at one point of time, you need to take up the technology, you need to embrace, you need to follow what others follow in order to go along with them, rather than get isolated, and one point of time you may go on out of sight. So with that few information, I thank the organizers of CIT for giving me an opportunity to talk about this introductory topic on this Industry 4.0. If you have any questions, probably you can interact with me. Thank you very much.
Thank you, sir. Thank you so much. Sir, other participants, if you have any questions, you can kindly text in the chat box, or if you want to clarify straight away, please, you can raise your hands. Let me allow you to come into the live, and you can talk with sir. Participants. Okay, sir. Sir, thank you so much for your session. So we have touched IoT, AI, and how these are highly useful in Industry 4.0. Thank you so much for your wonderful lecture, sir. And we want to hear a lot in forthcoming conferences and FTP also. Thank you so much, sir. We would like to see you.
Thank you. I'm leaving the meeting now.
Yes, sir. Yes, sir. Thank you, sir.
Thank you.
Participants, so you can join the next session by 1:30. So the next session will be handled by a scientist from DRDO. Thank you so much. So you go to enroll your attendance. 80% of attendance is mandatory to recommend you for the certificate. Hence, we request you to attend all the sessions. You don't fail and get enhancement in your knowledge. Thank you.